There are a number of concepts that we need to understand in order to actually work with algebra. The first concept is the concept of a variable. Now, in statistics, we met the concept of a variable. We said that a variable was a property of the individual that varies from one individual to another. In algebra, we use the term variable to mean something slightly different, but not entirely different. In algebra, a variable means one of two things. We might refer to a variable as a real-world quantity whose value we either don't know or haven't specified. So a variable might be the number of hours that we need to spend on a task, and our goal is to find out what that value is. So we assign a variable to it and then use algebra. Or a variable might be something like how much the Earth weighs. In that case, it's a number we could go out into the world and find out what it is, but it's an inconvenient number to work with. So we probably want to start out using a variable symbol for it, do whatever algebra we want to do, and then put that number in at the end. So a variable might be a real-world quantity. For example, we might say let X represent the number of seats on a bus. In that case, the number of seats on the bus is our variable. And then the letter X is the symbol that represents that variable. Now, the second way that we use the term variable, very confusingly, is to also say that the symbol is the variable. So we might say instead, a variable is the symbol that we use to represent some quantity. And with that definition, X is the variable itself. So in general, we'll use the term variable to refer both to the number of seats on the bus, or whatever quantity our variable represents, and also whatever symbol we're using to represent our variable. So, for example, we can look at the equation y equals 2x minus 1 and see that that equation contains two different variables. It contains an x, and it also contains a y. So the two variables are x and y, and each of those variables only appears one time. On the other hand, if we have the equation 3x minus 4 equals 2x plus 3, that only contains one variable. It only contains an x. We have an x here and another x here. So the variable appears two times, but it's the same variable each time. In particular, in the same context, the same variable symbol has to represent the same number. I think in this equation, every time it appears, x represents the number 7. And we'll see how to find that number out a little bit later. We also have, for example, formulas which are used to describe something about the world. So we might have the simple interest formula here. This formula contains 1, 2, 3, 4 different variables. And what this formula is doing is how we calculate simple interest. Now, each of these variables has a meaning in the real world. I represents the amount of interest, and that's going to be some kind of money. Usually we're going to say this is in dollars. P represents the amount of money that the interest is earned on. That's also an amount of money, so that's usually going to be in dollars. R represents the interest rate. Now, interest rates are usually described as a percentage, but when we put it into the formula, this needs to be as a decimal. And then T represents the amount of time over which the interest is earned. And in this formula, the amount of time is always measured in years. Now, what this formula is telling us then is that to take the amount of interest, we take P, the amount that the interest applies to, R, the interest rate as a decimal, and T, the time in years, and we multiply those together. When we write variables next to each other like that, that means multiply. And so that's telling us how simple interest is calculated. And one of the things we notice here is that when a variable has a real-world context, we actually need to think of two things to understand what that variable means. We need to know what the quantity is that that variable represents, but we also need to know what units that quantity is going to be measured in. That's because when we do the algebra, we're only going to actually work with numeric values, right? So a number. But in real life, what a number means depends on its units. So if we have t equals 4 as a time, well, that could mean 4 minutes, or 4 days, or 4 years, or 4 centuries. And those are all very different amounts of time. In the simple interest formula, we say that t represents the time in years. So if t equals 4, the time that that represents is 4 years. If we wanted to represent 4 months, we would say, okay, well, there are 12 months in a year. And when we're doing calculations with time, we often will pretend that the months are all the same size. And so each month is 1/12 of a year. To take 4 months, we take 4/12 of a year. And so if the amount of time we want to refer to is 4 months, we'll say t is equal not to 4, but to 4/12.